Hey everyone, and welcome to the Tom's Hardware Podcast. Let's see if we can adjust our screen a little bit to, well, nope. Uh, we will just, there we go. I think that is, anyhow. So, folks are piling in as usual, and we've got some special guests this week. Uh, as always, we're joined by Tom's Hardware Associate Editor Les Pounder and our resident Raspberry Pi expert, Ash Puckett. And this week, we have the two founders of Pimoroni, Paul Beech and Jon Williamson. Thank you so much for joining us. It's so exciting to have you on. I think most folks tuning in know that Pimoroni is an incredible leader in the maker community. You guys make like the top of the line, fantastic Pi accessories, kits, all that stuff. It's the amount of Pimoroni stuff that I have in my house is maybe not as impressive as they probably have in their house, but have a lot of stuff lying here within reach, from my STS Pi robot to my Unicorn Hat HD LED matrix, which is on a Raspberry Pi that's in one of their Pibo cases. So there's Pimoroni, really just amazing products. And we have the two folks who founded it right here with us to talk about some of their most exciting new products and to take your questions, of course. And we will also talk to them about some of the other things in the larger Pi community. For example, Paul, you designed the original Raspberry Pi logo, correct?
Mm-hmm. Yep.
So can you tell us what that was like? How did you get chosen for this, and why did you choose that logo?
So this was before the Pi even launched. In the kind of the buzz build up to it, the Liz launched a competition to create a logo, and it was one of those things where I've been following the story where they said they were going to release a computer for $25, $35. And this time everyone kind of thought this seems a bit different, because previously everything had kind of not quite happened. So me being a graphic designer, I said, okay, I'm inspired here. This is going to change everything. And I went for it. And they had about 1,000 entries. And there was a wait and waiting and waiting. And then one day, Liz dropped an email in my inbox saying, "Hey, you've won. Well done." And yeah, that was all different after that.
Wow. So do you still make products with a logo on them, or is that somebody else's responsibility now?
Generally, packaging has the logo on it. The logo, it's the foundations. I kind of hand it over and they get on with it and do their thing with it. But they make a lot of boards, so it's out there now.
Yes. So Paul's drawing is in all of our homes, all over the place. Have you seen anyone get a tattoo of it yet?
Yep. There are at least 3 people I've seen who have tattoos of it, which is, mildly scary. At some point, I'll probably do it.
So think about it. You're on their body forever. Your work. So when did John, Paul, when did the two of you decide to start Pimoroni, and what made you decide to buy it, to create it?
Shall I take this for a bit, Paul?
You go, John.
All right. I mean, Pimoroni started almost entirely by accident. Paul had been kind of playing around with a laser cutter at the local hackspace. Obviously, the Pi was out by now. It had been launched in February 2012. He had a unit, and he was looking at ways to make cases for it. Because in itself, the whole mission of the Raspberry Pi is to make computing more accessible, cheaper, and obviously it's not compatible with a bare circuit board. A bare circuit board is quite scary. It's quite intimidating. And what Paul wanted to do was design a case that could go around it, makes it feel more approachable, something that you're not scared to pick up, plug cables into, and kind of get on with. And he'd been working at a local hackspace, kind of running through prototypes. We were both working for different startups at the time. Paul was doing graphic design, I was doing software development. And we'd meet up in the pub after work a few times a week and kind of turn over the prototype of this case. And it kind of got to the point where every revision that he brought was so, the differences were so small that I was kind of like, we should put this online, we should sell it, we should, see what happens, you never know. And I think we ended up kind of crunching for a weekend. We built the website, we tied it into Amazon payments, PayPal payments. We put it up for sale and got our first order that night. That was July 17th, 2012. And then over the weekend, it got featured on the Raspberry Pi blog. And that's when it really took off. I mean, the sales were just crazy. I think we had like 2,000 units ordered within the space of a week. And at that point, we didn't have a laser cutter. We had no premises. We had literally nothing. So we spent like a month scrambling. We went and we bought a laser cutter. We found a facility that we could use, a really cheap, £250 a month unit to do the manufacturing in. We got in touch with Perspex, who supply all of our acrylic, kind of made our first order from them. And then we just started cutting cases. And literally that was it for 6 months. We just went in, cut cases, shipped cases, and then did the same thing the next day.
Wow. So when did you decide that you wanted to expand into all the areas that you're in now? I mean, you do a lot of boards, a lot of really complex electronics.
When we got bored of cutting cases, I think Paul can take it from there.
Yeah, so we had that first couple of weeks between kind of selling the first case and having a laser cutter where we could cut cases. And I remember we were driving back from the laser cutter place, and you had your phone set to go bing whenever there was a PayPal sale, John. And it was just the whole way home, it was going bing, bing, bing. And that was good. And then, we were running the laser cutters like 18, 24 hours. I think our longest shift was 48 hours of continuous production between me, John, and Rory. And then at the end of November, it was October 31st, Kickstarter said they were going to launch in the UK. And we were business geeks. We'd done startups before doing business stuff. And we said, oh, yeah, we want to be there at launch. We've been waiting for Kickstarter to launch. We should probably think of something to do on Kickstarter. And that led to the Parkade, which was the UK's first Kickstarter. Just because I sat there pressing F5 to launch the project, and they launched the website a few minutes early, so I got in there. Then I fell asleep, and John took over and started kind of spamming that news story everywhere. And the Parkade campaign did very well. That allowed us to get the pick and place machine. And from there, John basically learnt electronics from the ground up for the first time since he was like 15.
Wow, amazing. So speaking of things that are electronic, I know that you guys have an exciting new product that marries electronics with nature. I know, Paul, you have it in front of you?
Yeah, I've got some stuff here. Hey, there we go. Yeah, nice overhead camera. I think John's got the better demo here.
Oh, okay.
What I've got is dead plants.
Okay. So we'll go to John, who wants to show the new Grow Kit.
Cut to John. So this is a product we're quite excited about, this one, especially because the weather's so good at the moment, so we can make the most of the summer. And it's like a growing kit for the Raspberry Pi. So the idea is that you have these capacitive soil moisture sensors, and they can report back to the Pi via a kind of a mini hat that you stick on top. And the whole thing can monitor your kind of situation of your plants, keep an eye on the moisture levels. There's also light sensors and things on the mini hat itself so that you can kind of properly monitor the environment. And obviously you can get kind of alerts to your phone or whatever to tell you if they need watering. There's also kind of a piezo buzzer on the actual hat itself, so it can chirp at you if you need to give the plants some attention. And these products in themselves they've been kind of fun to develop. There's quite a lot of detail that's gone into it. I think more and more the difference between Pimoroni in the old days and these days is the amount of time we spend really scoping out what we want to achieve with the product and trying to make it as easy for the customer as possible to use, but without dumbing it down, so that they still have scope to extend it to do what they want it to do, rather than just, like a consumer product, you plug it in and it does one thing. So with the grow kits, the things like the moisture sensor sticks have been designed specifically so that you don't have to use them with our hat. You can buy these on their own. They literally send out a PWM pulse, which is paced depending on how much moisture they detect in the soil or the substance that you've got them inserted into. And that means that you can easily work with them on, say, Feather or Arduino or any other platform. In fact, I hooked one up to a coin cell and an LED, which literally is the simplest thing you could possibly do with it. And it'll just blink at a different rate depending on how much capacitance it detects. So if I grip the sensor, you can see it slows the pulsing down. If I let go of it, it'll speed up again.
Can this work outdoors?
No, these basically this is designed. So I think that the perfect person this is for is someone who's kind of like into the tech stuff, a bit geeky about it, but they're quite interested in getting into that kind of home growing. And this is only designed to work with that kind of initial stage of plants. So they're on the windowsill. Maybe you live in an apartment and you want to grow, you want to grow some chilies or something. We have little grow kits that go with it. So you get 3 pots and you get different varieties of chili. And these are just for starting those plants off. So it's those first few weeks of their life where they're kind of really susceptible, and the system can monitor it for you and kind of help you promote their growth and get them as healthy as possible before you might migrate them to bigger pots, take them outside, that kind of thing.
Oh, great. So really fantastic way for people who are stuck indoors to start a new hobby of growing chili and make their pie part of it.
A lot of us are, grow started before COVID-19 turned up. So it's not some rush to market for something that's COVID related. But, it is the time that people are stuck at home, and, it's a fun hobby. I do loads of cooking at home, and we have 2 kits. We have like a herb set, which is, I think it's rosemary, basil, and coriander. And we have the chili set, which gives you 3 grades of chili heat. And it's just a fun thing to do. I prep these with my daughter. We set them up. We kind of monitor them, check them daily, and it's just an entertaining way to get into technology, I think.
Wow, that's really, really impressive. I haven't seen anything like that in the pie space. I see Sergeant Lee wants to say hi to us. He is our Uber. He or she. I don't know for sure. Is our Uber fan, and always comes to these chats. So I know you guys also have some new I/O connectors for your breakout garden. What do you have to show us there?
Okay, I've got a whole smorgasbord of kind of sneak peeks here of stuff we're going to be doing. Let me show you on the close-up. So we've just released the I/O expander, which you gave us a nice review for. Thank you very much for that. Soon we're going to have the Super I/O version, which is going to be up to 12 ADCs and 12 PWMs, or a load of extra GPIOs. And again, this is all based on that kind of budget Nuvoton chip that Nico is so fond of. And it just adds a bit more. So that's one there. The rest of them are not breakouts. It's more shims and power stuff. And it's amazing. We've got 36 products in the pipeline at the moment, John. Something like that. So. Yeah, and we just need to get them out there. So to replace the Fat DAC, which we end-of-lifed for the Pirate Audio, we're going to release a Audio DAC shim, which just pops onto the Pi, gives you a line out from the digital audio. Wow. It's going to be slim, sleek. Let me see if I can show you. There's how it is on the Pi.
Yeah, this uses the friction fit header that Nico designed. He spent a lot of time engineering that particular kind of design of holes and plating to ensure that you get the best possible connection. Obviously, if your Pi pins are bent all over the place, it's going to struggle. But generally speaking, you can get a great lock. You don't need to solder, and it's just super convenient for people.
And this version here, you see it's got the hole here for the PoE header. we missed that out on the first prototype, and we just did the biggest face palm ever. Because we do make some very basic mistakes sometimes. We've also got the assistant shim, which is going to be, again, a friction fit, and it's going to have a left to right MEMS microphone on there and an LED matrix controller. So if you've seen the LED shim, it's got all the lights from that, plus a couple of mics just for doing assistant stuff, and a little button on there so you can initiate Google, Siri, whatever. I didn't say the whole phrase, so everybody's phone didn't start going off.
So that's for turning your Pi into an assistant?
Yeah. It adds microphones, it adds a button, and then you can wire the rest up.
Wow, that's really impressive.
And then wide input shim.
It's kind of cool. Sorry, Paul, go on.
Wide input shim is going to get an upgrade with the big buck shim. I think I've written the spec on the back here, fortunately. So 5 volt, 3 amp output, and 8 to 28 volts input. So just an Uber version of the wide input shim.
What does one do with the wide input shim?
If you want to run DC voltages into your Pi from random adapters, or if you want to do long runs of powering cables, that's one way of doing it. So it turns it, instead of using USB or USB-C, you would use a barrel jack of some description. So if you've got CCTV power, which is 12 volts, you can run it into the barrel jack here and power your Pi from kind of more tenuous or higher voltage sources.
Yeah, it's effectively like a solution for, I guess, slightly more industrial installations of the Pi. There's all sorts of systems out there that route, say, 12 volts, 24 volts to something. And if you want to put a Pi in it, like a CCTV or whatever, you need to down convert that voltage for the Pi.
Yep.
Oh, that makes sense.
So that will not be a shim, because the shim friction fit is not good for 3 amps. No. It will self-weld itself, possibly. Which, I think the final one I've got here is the on-off USB-C, which is that on-off shim, but for USB-C inputs, really. So fairly basic and useful.
Does that support safe shutdown?
That's exactly what it's for, yeah. So effectively, it's you have to run our software daemon on the Pi itself, but effectively that switch will allow you to soft power off the Pi and then bring it back to life again, so that you can, turn it off completely.
Now, even though it's Type-C, will it still work with older Pis than the Pi 4?
It will, yes. That's fine.
Wow, fantastic! Solving a problem that a lot of people have, wanting to turn their Pis on and off more easily without yanking the plug, and making it really, really simple. Can you stack these shims on top of each other? Like if you have, say, a fan shim and the on-off shim, is that feasible, or do you have to use an extender of some type?
Sometimes it's feasible.
Yeah, it comes down to the mechanics of it, because obviously it depends on the component heights on the boards, and the other consideration is the actual usage of the GPIO pins. So you'd want to check with something like pinout.xyz that you don't have conflicts. If the fan isn't using the same pin to drive the LED as, say, the on-off shim is using as the button reporting pin. We do try to make it sensible, so we try to kind of share functionality between pins in a way that is logically sensible, and so that products can work together, but it's not always possible.
And I know you guys have, I think, a configurator on your site of some kind that if you want to use multiple Pimoroni hats together, it tells you what it tells you which one is using which pins, right? I was using that the other day, trying to figure out whether my Explorer Hat Pro could work with the pan tilt hat, and it told me that they couldn't. So my son was like, "So don't make it tilt." And I said, "I got to figure out something else." But that's that's very useful to know, because there's such a huge ecosystem of Pimoroni products, and they can all work together.
That kind of configuration Explorer isn't actually a Pimoroni product, but it is developed by Phil, who's our amazing software guy. So it's his own kind of pet passion project. And I guess a good thing about that is it means it includes competitors' boards as well. So it embraces the whole Pi ecosystem. It's not just about what we produce.
Oh, cool. Did I not see it? Did I see it on a different site? I'm sorry. But
we reference it all the time. Like, it's a super great tool, and it's by Phil, who's one of our team. So it's actually incredibly useful for exactly the problem you were trying to solve. And we promote it left, right, and centre. But I want to make sure he gets the credit because it's not our thing.
Yeah, that makes total sense. So I'm opening it up to other folks to ask questions. I know Les has worked with you guys for a long time. Is there anything you want to ask Paul and John?
Yeah, the Parkade is a really popular product for you guys. And I want to know why you created Parkade. What was the need that you addressed with it? What did you want to achieve with it? I think I'm getting at.
It was when we originally created the Parkade, it was the wrong way round. Kickstarter was launching in the UK, so we wanted a project for it. And we love retro gaming. The Pi was just getting good at retro gaming, so Parkade was the answer.
I think it's also important that for us, there are other mini arcade cabinets out there. There's way more now than there were when Parkade came out. But the aesthetic was always wrong, and we knew that if Paul did the aesthetic, it would be right. And I think it's one of my favourite things about Parkade. In fact, I've got one right up there in the corner. That while it's clearly a classic arcade cabinet-inspired product, it actually has quite modern flair to the design, and the simplicity of it. It's not a fussy design, so I think it feels like it fits in your living room in 2020. Even though it's harking back to like a smoky bar in 1980s, and I think it's a really important aspect of what Parkade is. There's a lot of other kits out there, and I'm not being catty, but that I don't dig the aesthetic of, and I think the thing about Parkade is it kind of sits in a really kind of clever position where it's viable now, but it also reminds you of what was before.
But this was the thing when we came into kind of making and everything. This was what drove us. We were looking at green circuit boards and going, why does this look this way? And we kind of have design and web background, and we were like, why does this look like the 1980s? And you started making the first circuit board we made, apart from Parkade, was Pi Glow. Just because you wanted to see things at arbitrary angles and make something a bit different. That was what drove us.
Well, that actually reminds me, someone once said to me that the development of your products is based on the fact that you want to learn a new skill. So Pi Glow was there because you wanted to learn better PCB production. Parkade is there because you had these laser cutters that could do all this fantastic work. Is there any truth behind that? So you're learning new skills by releasing new products and building up your skills with each product?
Well, I'll correct you slightly in that you said that Pi Glow was designed to improve our PCB production. But actually, Pi Glow was designed because we'd never produced a PCB before in our lives. It was literally the first thing we put on a pick and place machine and went, "Oh, that's how it works. Brilliant." So, I think I know that certainly the Parkade, the development of the electronic side of that was an uphill struggle for us. It was completely arduous. We went through something like 15 PCB revisions. But that's because we started at literally nothing. We had no knowledge. We didn't know what the tools were. We didn't know how you produce these things. We didn't really know anything about electronics at all. And you absorb a lot in those early days of learning a new skill, but it takes a lot of time and it takes a lot of headspace to kind of fully appreciate all of the nuances of things you're trying to achieve. And even then, you do a bad job those first few times, right? It's never going to be great on number one.
You remember the screens for Parkade?
Screens?
Finding the screens for Parkade.
I'm going to stick my fingers in my ears and start saying la 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 in a minute.
That caused us so much stress. Because there we weren't learning to design drivers for LCDs. We were just trying to find kind of an arcade aspect LCD. And that was us learning about supply chain and sourcing in the Far East. Again, we had no knowledge of this. And that broke us a little bit. That was harsh.
I think you'd kind of assume, like when we started out Parkade is a great example. When we started that, we knew how to laser cut stuff. So the chassis was kind of a done deal. We understood. We had to work out how to powder coat it, and that was another complication, but it wasn't too bad. The PCB side, we knew nothing. We were starting from scratch, huge amounts of effort. But the things that we didn't think would be hard were hard. Like, you would imagine you could just call up China and say, I want 1,000 screens like this. You can't. It's not possible. And like Paul says, the supply chain on products like that it's a nightmare. Talking to the right people is really difficult. And the whole process, you've got to be prepared to just graft at it over and over again. And obviously it gets easier. Now we understand these things, and we have, a sourcing team in the Far East. We can just talk to them and they'll deal with all of this. But when you're there at the start and you're kind of on your own, the whole thing is so hard. It's such hard work to get through it and kind of get through the barriers that are there.
We're doing this now, aren't we? Because 32-bit, we're learning injection molding, like on a bigger scale. So, Les, you are absolutely right.
Thank you very much. I've got that written down now as well. Actually, it leads me on nicely. 32-bit, someone mentioned in the comments that they're looking forward to the 32-bit. Now, for anyone who doesn't know what that is, can you tell everyone what 32-bit actually is?
So 32-bit is a retro-inspired but modern hardware handheld console. I don't have one with me. Have you got one, Paul? You've got some there, right?
I've got a stack of stuff here. Yeah.
So the whole point of this was that we wanted to create
so many prototypes.
Oh yeah. So the whole thing with 32-bit is that traditionally I'm a software developer and I like writing software, but actually when I started getting into hardware, writing software that makes hardware do stuff is way more fun than just sitting in front of a Windows PC or a Mac and mashing the keyboard. And kind of as an extension of that, you saw things like Pico 8 turning up, the virtual console, and the amount of fun you can have when you're kind of given a constrained environment and a decent programming language, and you can just hack away without kind of the complexity of modern systems. I mean, they're kind of simplified in some ways, but in other ways, if you ask someone what specs your PC, they can give you 1,000 different answers. What we wanted to do was create a single platform, consistent hardware, consistent kind of software APIs that people could hack on in a similar way to Pico 8, but where they actually have a physical piece of hardware in their hands. And they can share. The whole point is like, develop a game, develop a demo, prototype, whatever, share it, riff on it, send it to someone else, they can add the audio, send it to another person, they'll improve the sprites, and that's the dream of it. Whether it ever comes to that kind of level of take up, who knows? But that's the point. That's why we did it.
Yeah, so close. So close.
It is so close. That one, 32-bit has actually been compared to Parkade, it's similar to Parkade in that there are bits of it that we're fine with. We know it. We've done it before, and there are new bits like the injection molding where new complexities come in. Things that you wouldn't even think could be a problem are things that you're now trying to solve and work through. So it's interesting. It's always interesting, but it's never easy.
So is it going to be a Game Boy-like device that people use for portable gaming?
Yeah, effectively, it's very similar in format to something like the Game Boy Advance. So that kind of classic landscape format, screen in the middle, controls left and right. Something small, you can throw it in your pocket. I think Paul's got one. If you can zoom his view, you can probably see it a bit better. But there were a few
I see if we can do the overhead.
There you go. There were a few things that were very important to us on this. One was that the controls feel great. There's nothing worse than bad controls when you're playing the game, and that certain aspects of it, while trying to kind of hark to the retro vibe, that certain aspects of it were very modern. So things like the screen is a really great IPS display. It's not acceptable to us to throw like a really rubbish TN LCD on something and call it done. It has to be vibrant and the colors have to look great. And things like having the analog stick is a nice kind of hint towards the modern gaming world, while still kind of trying to embrace how handheld gaming used to be 10, 20 years ago.
So is this going to take a Pi Zero?
No, it's all inbuilt. So it runs. The whole thing runs on an STM ARM chip. It's quite a high spec chip. It has it's got a megabyte of RAM, which is pretty rare. and we have an external quad SPI flash chip for the actual code and the stuff that runs on the system. And the screen is connected via DPI, so similar to Hyperpixel, you get 60 frames a second in full color. So you get like a really slick, quite powerful experience out of it, even though it's just a little ARM chip in there connected to a 3.5-inch display.
Yeah, we wanted hardware limitations in there, so you had a challenge to learn to program well.
Yeah, nothing against the Pi at all, but we didn't want a handheld console that takes 2 minutes to boot, and then you have to worry about whether your network stack is up to date. It's completely against the principle of what 32-bit is. It's about handheld consoles, they start up, or they used to. They don't anymore, but they just start up, and you don't have to download updates for an hour before you get to play. It's meant to be that kind of simplicity of retro computing.
So how will you run an emulator on it?
You have internal flash on the device, so we put 32 megabytes of internal flash in the device, so you can copy things in that way. There's also a micro SD card on the back, so you can put in an SD card with images. People have already got running, so our focus is on the creation aspect, so designing your own games and kind of learning the skills. But part of the beta testing process is that we've got like a Discord with a load of people who already have these devices. There's about 100 or 200 of them out there, and they're constantly kind of sharing examples of what they're getting running on it. And we've got people that, I think we've got like a MPEG video player, we've got at least an NES emulator, I think, a Game Boy emulator. I think someone's playing around with some stuff a little bit more advanced than that. But again, a lot of the work they're doing is kind of like, well, this is a 400 megahertz ARM chip or 480. How do I get an emulator to actually run on that at a decent frame rate?
Yeah, so it's about learning how to make emulators or games, not about just running emulated games at all. Because if you wanted to do that, you could go into the middle of Shenzhen, pick up a rock, throw it, and hit 10 devices that will emulate. So it's why do that again?
Having said that, I think it's wild that like the beta backers are getting this stuff to run. It's awesome. It's just not kind of the point for us. And I'll definitely be using the stuff that they're producing to play emulated games on it. But it's not the reason we did it. If you were just making an emulator, there are much easier routes to take, I think. But yeah, it's still cool stuff.
Yeah, no doubt. So, Ash, I know you're someone who really likes to play emulated games. In fact, you have a Parkade behind you. She always has it on every show, and people are constantly asking her what it is, so she always has a chance to talk about Parkade. What do you? I know you had something that you wanted to talk about today.
Well, first, to the Pimoroni team who's here with us, on behalf of everybody who's been in my living room and stopped and said, "Whoa, is that an arcade cabinet?" Thank you. It's really awesome. So I know y'all put a lot of work into making that happen. But I had something to show off today called Stressberry, actually. If you guys have heard of that, it's an application designed to put your Raspberry Pi under stress by working the CPU, and it can plot the temperature of the Pi throughout the test. And the test itself can be exported into a graph, which is a really good visual if you want to comprehend like what's going on throughout the stress test. So it's really useful if you want to test maybe like a certain case. I know that Les had a case last week, the gym case. Maybe he wanted to compare it to another one to see how well it handled heat. Or maybe you had just a crazy Raspberry Pi project with a lot of add-ons, and you want to see how well it's going to perform temperature-wise under heavy loads. So it's just really easy to set up. So I can show you guys really quick. Let me make my face disappear here. And I've got a link right above me up to the GitHub for Stressberry if you want to check it out in person. But to install it, it's just a really simple command. If you look below me, you'll need to install Stress, and then you can install Stressberry. It's just really easy. Sudo apt install Stress, and then pip install Stressberry. And once you install it, you can run it. And if you look over to the side, I've got a window here of a Pi that I'm remoted into. And above the command line where I can type in, you'll see what it looks like as it goes through the stress test, giving a line of the temperature while it's running through everything. So once the stress test has been run, you can run this command, and it will plot the entire thing into a graph, and it looks something like this. So if you want to test a whole bunch of different devices, you can run through this test, and there's a whole lot of ways that you can actually process the data, and maybe you have a couple different tests you want to overlap and see how they look together. You can go to the GitHub to check out the different commands you can use, but Stressberry is really useful if you want to see how your Raspberry Pi project is running temperature-wise.
Yeah, I've used it the other day to test out some cases. Do you guys use it at Pimoroni? Ever use Stressberry at Pimoroni to test out your cooling products?
I'm
Yep.
trying to. Was it Stressberry?
Yeah, Stressberry just makes it a lot easier. What we have for next time we start doing bilge tank again is somebody made a small frying pan for Phil, like handmade a tiny frying pan. We want to try cooking an egg on top of the Pi 4 using Stressberry.
Oh man,
It's around here somewhere.
Oh, do you think you can? Because just a little aside, those of you who have followed us on Tom's Hardware for a while know that we did an experiment like this with PC CPUs last fall. But since everybody's done eggs, we did pancakes, and we did a face-off AMD versus Intel, which gives you better pancakes. And the AMD processor turned itself off. So we couldn't cook the pancakes at all because it had some kind of heat protections. The Intel one eventually cooked pancakes. What we found is that you need to get really, really hot to really do the cooking. And doesn't the Pi 4 CPU throttle itself down at 85? 85
Yeah.
It's around there, yeah.
Yeah.
80 degrees, it starts rolling off. And I think the answer is it wouldn't work very well. The Pi 4, even though it's the first one that you really need thermal management, it sips power and it's very efficient compared to like the other devices out there. Like you see some of them and they're covered in heatsink just to operate it all.
Yeah, I wish there was a way. I don't know. Have you guys managed to push? Has anybody who's listening or watching managed to get an overclock on the Pi 4 higher than 2147 megahertz? Nope.
I think that's pretty high.
I think you're locked there, aren't you?
I mean, they don't say that you are, but I have never gotten above 2147, and it seems that no matter how good your cooling is, like we did the 2147 no problem with the Pimoroni fan shen, which by the way is a fantastic fan because it doesn't take up much space and you just plop it right on there. But we had no problem. I don't think we ever got above like 55 or 60, even at 2147. So, it's hard.
You don't need that much.
That's quite a brutal overclock, really, though, isn't it? I mean,
yeah.
you're getting a lot out of the silicon for that.
Yeah,
it should not stop you putting really big fans on the Pi, though, just for your own amusement.
Yeah, that's the thing. I was kind of hoping we could do liquid nitrogen cooling and get some benefit out of it because we have a guy who does that for PCs all the time. When we found that simple air cooling was good enough, it was kind of that. Wait, someone in the chat says try running one with an SDR on USB, then you can fry an egg. All right. Well, there's a solution. So Les, I know you had a couple of things that you want to show today, including a new case that you've gotten access to.
Indeed, yes. Cooler Master have sent us a prototype of their new case. I'm going to go to the overhead camera on this because I'm just completely invisible because the lights are so bright on my desk. So let's try this. There we go. So there's the overhead camera. This is Cooler Master's Pi Case 40, which was a Kickstarter project a few weeks back. And this is a prototype. It hasn't got Cooler Master logo on it just yet. And I have to say, I haven't done any thermal testing with this yet. But I'm quite intrigued by this case, and simply because it addresses a few issues that I've had with previous cases, including the Acacia Gem Pro. Port access is fantastic. I've got access to all the ports that I need. I've also got access for cables to come out for the camera and a display, which some cases don't have. And then those who are noticing this will see that there's no GPIO access. And a lot of cases don't have that, just a very thin slot, but this actually does. If I just pull this out here, underneath the silicon or plastic, you can see there's a full GPIO access there. And I can put hats on. Yes, they are orientated 90 degrees, but I can put a hat on there and use it. So I'm going to be taking this case through its paces in the next week. Oh, there's a button there as well, which you can program as an on-off button or whatever you want. So that's one of the things to look at. The next thing, this is slightly bigger than my desk, so we'll have a go. This is, let's try and get it in shot. There's me. Hello. It's RazPad 3. And this is a Raspberry Pi 4 based tablet. And you can see it's a wedge of a tablet. And it has GPIO access. But inside, and I've taken it apart slightly before I came on, we have a fan. And I'm going to be honest, I've powered this up, and it is the whiniest fan known to mankind. It is really noisy. I'm sorry to say that, but it is the truth. It is really noisy. It's at 100% all of the time to keep the Pi cool. But the internals are really good. We have a Pi 4. We have 3 18650 batteries. And we have this wonderful control board that links in with standard ports. So micro HDMI, USB-C, Ethernet, that sort of thing. It's all there ready to go. Just plug in. And it's even got this fantastic, can I bring it up and get it in focus? Let's just double check. We've got this tiny breakout card for a micro SD that plugs in using a flat flex cable into the board. It's so tiny and so fragile, but it was such a joy to see. Because now I can plug in.
Or does it come put together?
It comes partially put together. So all the wiring you see here and the Pi is not included in this Kickstarter that I got. You have to put in yourself. And some of these wires are just off-the-shelf ones, like the USB wires and HDMI wires. Some of them are custom made, and you can tell because of the heat shrink. I gave it away. So this USB wire is a homemade wire, and that's just a really thin Ethernet there. But it's a nice piece of kit, and I'm going to enjoy playing around with this. But I'm just waiting for the official software to come out. There's a little fault at the moment where when it boots, it kernel panics, which is never a good thing. But it does run standard Raspbian, so Raspberry Pi OS. So we're going to have a good play with this, do a few tests, and write it up and put it on the site.
So I have a question for everyone here, including our viewers and especially our special guest from Pimoroni. What do you like to use as a touch-friendly UI for Raspberry Pi? Have you seen a good one?
Kind of, yeah. Hyperpixel. I think Phil accidentally made about the best multi-touch driver for Pi, and yeah, he's still not quite sure how. I think because we were using some weird chip, so he spent a couple of weeks abstracting away a lot of stuff to get multi-touch working.
But I mean, as far beyond the driver level, have you seen a good way of manipulating the UI to make it more touch friendly?
You're talking about UX? No, not so much. No, just using WX widgets or using Qt.
Yeah. I mean, there's not Raspberry Pi OS. The desktop environment isn't really optimized for touch use. I mean, it's doable, but it's just not designed for that, really.
Yeah, I've recently set up a touchscreen unit, and I found that, and I was thinking, this is kind of a big opportunity for somebody to make, or maybe the foundation to build into the OS better touch-friendly features. There's a lot of people using touch screens, but it doesn't seem like you've got a lot of things that are really friendly. Nothing brilliant apart from Hyperpixel, no good UI. Fair enough. Well, I know we've got a bunch of people in the chat. I haven't seen a lot of new questions. I do have one final question for our special guest, which is, what do you think what do you think is lacking in the Pi ecosystem that you would like to see? What products are there out there that haven't been made yet, or that you've been thinking about that it just isn't being done well right now?
That's a good question, Abraham. I'm going to think now.
Yeah, I think it comes down to what you think the pie should be, or what you think the point of it is. I think, and I think one place where it may be lacking a little is that when it comes to like Arduino, there's a big focus on the electronic side. So hooking things up to the GPIO, bare wire, breadboards, all that kind of thing. Because that's kind of all you can do with an Arduino. You can't connect it to an HDMI screen and a USB keyboard. And on the Raspberry Pi side, I think the focus is much more on these kind of, the hats, the FATs, these single-purpose, plug them in activity boards. And there's nothing wrong with that, but I think it has taken away a little bit from the more raw experience of, wiring components together and seeing how they interact and how circuits work.
Fair enough. Someone in chat says cabled breakout GPIO would be nice for hats, or a decent riser to get over case. Yeah, I agree. I think that could be better. Someone else says good Pi laptop, please. Well, we did show one that is a pretty decent, the Picro 2 a couple of weeks ago, and that's pretty decent. I don't know if it's a fantastic laptop for just using as a laptop, but it seems like a good learning opportunity. And one of the things I think that Pimoroni has done, which is really fantastic, is all the kits that are really designed to help with learning. Things like the radio kit and the scroll kit that are really made to teach kids, or kids of all ages, about how to set up their Pi and how to program. Are you guys thinking about any more products like that that are really just turnkey educational products?
Yep.
Oh yeah, that's obviously one. Yeah.
So what we've been doing with things like the Pirate Audio boards, we're going to do with other boards, is take away the soldering. Soldering is something people should learn to do, but you shouldn't have to learn to do it. So we've made all our audio boards non-solder if you don't want to solder. And, we're going to do the same with other small boards that were previously soldering only. And then we'll refresh the kits and hopefully level up the instructions so they have the video, they have the good learning experience and the content, so that they're a step beyond even what we've done before. Because we're still not at the point where you can leave a 6 to 8 year old alone with these and expect a good result. And that's still missing the mark. Even when we do things right, we're not quite there.
Yeah, but on the other hand, I just want to opine for all the parents out there that I don't necessarily always want to leave my 8-year-old alone with them. Not because I don't trust him. I totally do. I just enjoy doing it with him. We have a lot of fun doing these things together. And sometimes it's a matter of, like with the STS Pi, he sat there and I did the really hard, the hard parts of trying to get the plastic together and screw the bolts and all that. But once we had it set up, he's taking it while I'm at work and trying to like program it to do things, getting into like trying to program a web interface with Flask and things like that. So I think what's great is when you have things that use an open ecosystem like the Raspberry Pi, then the skills are very transferable. And my kid learns Python and then he can use it on another set and he can use it all over the place, as opposed to a lot of the kid kits that are out there that are very proprietary. And it's like, you just learn our block-based coding language and that's it. If you try to use something else, good luck to you. Or
it's learning on Rails, where there's you will go down here and you will do this, but you don't really learn because you've just gone through a series of steps. I hate that.
Right. There's so many kid products like that. And that's why I love things that use the Raspberry Pi. I love things that use Python or even Scratch 3 that are open. These are open languages that once a kid learns them, they can take it and build on that skill. Whereas other things, it's just like, I used to review a lot of kid robots and they were very frustrating. So anyhow, I want to thank Thank our special guests, Paul and John, for joining us. As always, the Tom's Hardware Podcast is on at 2:30 p.m. Eastern, 7:30 p.m. BST for our UK audience, and you will find us archived on YouTube, Facebook, and wherever audio podcasts are available. Thanks, everyone, and we'll see you next week.
Thank you.
See you later.